So have you ever wondered how you can add some cool drag and dropping to your games? You know, the kind of feature at the heart of an inventory system, or perhaps some potion crafting. Well, today we're going to see that in our modern game engines, that's actually quite easy to do. Hello everyone, I'm Mina, and in this Godot 4 C# tutorial, we're going to discover how straightforward it is to create a UI drag and drop system in this engine. Oh, and by the way, this tutorial topic was actually suggested by one of my Patreon members. So if you too have ideas of tutorials you'd like me to make, or if you wanted to support the channel and get some exclusive rewards, like minigames, tools, plugins and assets, you can check out my Patreon. So feel free to have a look. So in this tutorial, I want to talk about a really great built-in Godot 4 feature that makes it super easy to implement drag and drop for UI elements. Cause did you know that there's actually ready-made functions that you can override to instantly get this behavior on basically any control node in your Godot 4 games? In short, the trick is the following. First of all, for all the elements you want to be draggable, or in other words, the things that you can actually click and grab with your mouse, you need to override the getDragData function that is available for every control node. For your element to actually be draggable, this method has to return a non-null value, and this value will be the piece of data that is stored during the drag, and that typically you can read back on drop. And so then, to actually take care of this drop phase, meaning to allow some elements in your UI to receive your drag data and end the drag and drop mechanic, you need to give those elements a script where you implement two functions, canDropData and dropData. As their names imply, the first method is called on your drop-compatible control nodes to determine whether the current drag is okay for dropping. This can be really interesting if you have various types of drag and drop in your game, and you want a drop zone to only work for one of those drag and drop modes. The second function, dropData, is where you'll truly end the drag and drop, optionally getting back the drag data and wrapping up your logic. Alright, now that we know how those built-in functions allow us to easily implement a drag and drop mechanic in our Godot 4 games, let's see an actual example. So our goal here will be to take this potion icon, this potion sprite, and drag and drop it on the various colored areas to change the tint of the liquid inside. This tint update will be done just by switching between the different variations of icons from this very cool asset pack by Didend 1100. Meaning that, in short, we'll want to know two things. On the drag side, we'll have to store what shape of potion bottle we're using, so that the visual is switched properly for an equivalent shape with just a different liquid color. And on the drop side, we'll have to know what color is associated with this specific drop zone. So first, let's say that we give our potion sprite a C# script with the getDragData function overridden inside. This method will return a basic dictionary with two keys. Shape, which is the ID of the icon potion shape, and source, which is a reference to this origin control texture rect. The reference will allow us to update the icon of the potion with the right color once we've dropped our drag preview on a color slot, and we'll define our shape ID as a class variable that is exported in the inspector, so that we can easily set it to the right value for each instance of our potion script in the scene. For the drag preview, we'll use Godot's setDragPreview built-in function and pass it a copy of our potion sprite. It's really important to remember to duplicate the element and not just pass it as is, cause Godot 4's ready-made drag and drop system automatically frees the preview at the end of the drag, so it has to be a new separate node if we don't want it to be just simply deleted at one point. Also, as a side note, this ready function will make sure that we initialize each potion icon with the right shape and an arbitrary color, which here is white. Now let's make a second C# script for the drop zones at the bottom. This script will of course define the canDropData and dropData functions, and here's how they'll work. The canDropData check logic will just look at the incoming data and ensure that it's a dictionary with a shape key and a source key. Then the drop data function will use this shape key and the color associated with this drop zone, which again will define as an exported variable in the inspector, to compute the path of the new potion icon to use. And finally, it will assign this new texture to the source texture rec node to actually update the visual in the UI. And that's it! If we try this out, we see that now, whenever we click and drag on our potion sprites, a little drag preview starts to follow our mouse, and we can move it around as we want. Then if we release the mouse button on any of the colored drop zones, our drop check and drop logic are executed, and the original sprite image is properly updated with the equivalent icon for this new color. If we release or drag anywhere else on the screen, then the drag and drop simply fails and nothing happens, except for the drag preview being automatically deleted. So here we are, we've quickly set up a basic drag and drop system for our Godot 4 game using just a couple of built-in functions in C# code. However, just before wrapping up this tutorial, I want to point out something. Although this built-in drag and drop system is really cool and quick to set up, it also has its limitations. In particular, with these ready-made hooks, you can force a drag from a script with the aptly named force drag function, but you can't interrupt a drag. So for example, if you want to set up the typical right-click to stop the drag feature, you can't really do it as is. If you need to really customize your drag and drop feature and give it a bit more power, you might need to code it all up yourself. In which case, here are some pointers and a basic boilerplate to help you implement this. The idea here is globally the same as before, except that we'll need to manually check for the left mouse button up and down events and the actual preview drag. To better organize our codebase, it can be nice to do that in a dedicated drag manager script, which we can mark as an autoload in our Godot project to make it easily accessible from anywhere in our codebase. By the way, if you're not too familiar with this concept of autoloads, we actually talked about it a few times in this series already, for example in those previous episodes. In short, autoloads are Godot's built-in way of declaring global cross-scene nodes or scripts that are auto-instantiated when the game starts at the root of the game tree, and can therefore be accessed from any script and may contain session-wide data. But anyway, in our case, our global drag manager logic will need a few functions. First, we'll have something to start our drags. This will be equivalent to Godot's getDragData built-in, so we'll need to take the drag data to use for this drag and drop phase as parameter and store it in our drag manager class alongside our drag preview control. Then the stop drag and finish drag functions will basically be two ways of ending our drags. If we actually drop the dragged element on a compatible UI control, then we'll call the finish drag method that runs some specific on-success logic. Else, we'll simply skip directly to the stop drag section and clean up our data and our preview. Note that here I'm replicating Godot's built-in drag and drop system mechanic where I automatically free the drag preview when the drag ends. The last thing is to make sure that our drag preview follows the mouse, which we can do in our drag manager's input function, so that when we get an input event mouse motion input, we use its global position to update the position of our preview. By the way, we should also set it to this proper position when the drag first starts, so that there aren't some in-between frames with the preview improperly stuck in the corner of the screen. And also note that we're not actually going to trigger the beginning and the end of our drag from within this global script, for example using this same input hook, because that would make it quite hard to properly specify which elements are draggable or not. Instead, we'll use the UI signals of the draggable elements and of the drop zones, typically the UI input event, to call our drag and drop methods. Here's a little example of how it could work for something similar to a previous use case. Of course, the GUI input signals need to be connected in the inspector of the node to these callback functions to really call the right logic when the player interacts with these UI elements. So here you see that in these input logic bits, we just check whether we get a press or a release of the left mouse button, and then we call the appropriate method from our global drag manager autoload, which means that we can also check for specific inputs, like a right click, and in that case, enforce an early stop of our drag by just calling the stop drag function, just as we wanted. But in any case, here you go. You now know how to easily set up a UI drag and drop system using Godot 4's built-in utilities, and even how to rewrite it on your own to really customize it to your liking, thanks to your own signal-based features. I really hope you liked this video, and of course, I want to thank all of my Patreons for the support. In particular, a huge thank you to my Square member, René Hitzke, and to Sébastien Perouf, who just joined as a new Patreon line member. Also, if you enjoyed the video, feel free to like it, subscribe to the channel to not miss the next ones, and perhaps even drop a comment down below with ideas of Godot tricks that you'd like to learn. As always, thanks a lot for watching, and take care.